So last week we were speaking about how would you name an organic compound. And I told you that this week I will be using, instead of PowerPoints, I will be using a whiteboard, okay? So that I would be capable of actually drawing the atoms and drawing everything on the board. Some things they might be useful to use the PowerPoint, others I'll be using this method. So let's say we have this compound. One bromo, one chloro, ethane. So the first thing that we will do is we note that we're going to have 4 different groups. Okay? We note that we have 4 different groups. And the priority is going to be given depending on the mass of each atom attached to the carbon. Here you have 4 different atoms, therefore that's 1, 2, 3, 4. You'd be surprised how many times this will be the case. In fact, most of the time you'll have at least 1 carbon, 1 hydrogen, 1 heteroatom, and the 4th atom would be the one that you would need to consider most. So the highest priority is given 1, the lowest priority is given the number 4. If there is a tie, and so let's write it like this. If there is a tie, we have to look at what's happening in the tie. Okay? So we have to consider atoms that are a distance of 2 away. So these 2 carbons are tied, but one of them has a hydrogen and the other one does not, yes?
Jista' jkun biex niċċekkja dil-karta compare ħatibatilna fuq VLE se.
What I'm doing right now?
Il-page, compare the atomic number of the atoms.
I can send you these in a document, okay? I won't upload, I will upload the video, but I won't upload the whiteboard itself because I've had problems uploading whiteboards. They're either too small because they will be just 1 picture, or else I will have to give you access to change them. So what I will do, I will take screenshots, or I will just post, copy each individual sentence.
The document.
And the document.
All right, thank you, sir.
Welcome. So if there is a tie, you go and try to find and see which is the highest priority by going 2 carbons down. So we would be comparing the blues. And one has 3 hydrogens, the other one has 2 hydrogens and the carbon. Therefore, the carbon would be the highest priority group. If there is still a tie, go to carbon number 3. Okay? And in fact, later on, we'll actually discuss limonene. Okay? Because limonene has 1 stereocenter, and we would need to do something like this. So we'll leave it for the end of the lesson. If we have isotopes, okay? Remember, let's say you have deuterium and hydrogen. Deuterium has higher priority because it has an atomic mass of 2 and not of 1. And if you have double or triple bonds, okay, you would have to say that carbon and oxygen, for example, carbon connected to 1 oxygen, so we will repeat the carbon and oxygen, But then we will also add an extra carbon and an extra oxygen as phantom atoms. So these two are then called phantom atoms. Okay? So a phantom atom would have no other group attached to it. The only reason why we would use it would be to compare priorities. Okay? So we only use these to compare priorities. Then, yes?
I didn't quite understand what the phantom atom did.
Okay, give me a second. Let me see if I have an example of the phantom atom. Yes, there is an example. Now, we'll do the example later on.
Okay, thank you.
Okay? Because I forgot which ones I put in. Rotate the molecule so that the lowest priority is at the back, and then see whether it's going to be R or S. Okay? If it rotates 1, 2, 3 are rotating to the left, it will be S. To the right, it will be R. So let's actually jump into a few examples. Mala. That means that is hydrogen. Now, the best way to do these is to build the structures. Okay? The best way to do these is to build the structures. Okay? And it's very important to build the structures because that means it's going in and the hydrogen is coming out. And to be fair, that is not the arrangement you would want it at the end. Okay? Remember, you would always need to consider them as in or out, depending on how they are. So here you have 4 groups. Okay? You have carbon, carbon, hydrogen, and oxygen. Now, I love, at this point, to write them out. Okay? So I can see what I've got. Now, the double bond, I'm not sure who asked me the question. I broke part of the double bond. And I said, let's add the same element to both of them. Okay? So the carbon is as if it's bonded to 2 oxygens, and the oxygen is as if it's bonded to 2 carbons. And in fact, a double bond, that's what it is. They are sharing 2 bonds. They are sharing 2 pairs of electrons. So it's easy to go and say, we have carbon bonded to 2 oxygens there. Yes?
Mela, emmek, int kellek tamel COOC, mux OH, emisfel? Inti penġejt COH.
Oh, yes.
All right.
I was looking at the one on top, sorry.
All right.
Yes?
Sorry, ma tantx nifhem x'inti tgħid tal-aħdar.
Tal-aħdar, mela. How many bonds does the carbon has with the oxygen?
2.
Bin saqsin il-mistoqsija ma nafx min kienet.
Jiena.
How many bonds does the carbon has with the oxygen?
2.
2. So to represent that, we can draw it as, okay? And the oxygen, the same thing, 2 bonds with the carbon. These 2 are called phantom atoms. They are not really there. They are just there to show us how many times it's bonded to the same carbon. Because it has a double bond, it's actually bonded to carbon twice, right?
Mhm.
Therefore, because it's bonded twice, we draw it twice. We draw the original carbon-oxygen bond, and we draw what we call a phantom atom. It's not there. It's just showing how many times the carbon is bonded to oxygen.
Fair.
Thank you.
Allura, as such, dawn, aħna jisna qegħdin niftħu double bond biex naraw il-priority.
Eżatt, dak kull met nagħmlu.
Okay.
Okay? Now.
Sir. Issi meta penġejt ix-shadow atom.
Sorry?
Issi li penġejt. Hello?
Mela, erġa' ripeti mistoqsija?
Qedlek issi dikka penġejta biex jekk just in case kollok OH u double bond.
Yes. Fil-fatt ħajkonna bżonna f'dal każ. Okay? Yo, le, ma naf. We'll work it out. Okay? So, let's assign the priorities. So, 1 and 4, they're easy. Then you have 2 carbons. One carbon has a hydrogen, a carbon, and a hydrogen. The other one has an oxygen, oxygen, and oxygen. So if we compare the highest priorities, oxygen and carbon, okay, I'll tell you, okay. That's 3 and that's 4. I didn't draw the nitrogen because it's too far away. So I did not need to include it. Remember, it's the atoms conjoined to the adjacent carbon. It would be this one here, the nitrogen. It's too far away. We were comparing the green ones.
Sir, fil-diagram għandek herbivores. I mean, żewġ fours.
Oh, sorry. I forgot my numbers. Okay, so that would be 1, 2, 3, 4. Now.
Sorry, could I just ask you something? When you open the double bond, I get why you put O and O. But the second C, like, how would it help? Can you hear out? Does it smile, Nisa?
Yes.
All right. Naf taħt il-double bond, għalfej għamilt C u koll. I mean.
So the carbon is attached to 2 oxygens, but the oxygens would be attached to 2 carbons.
Okay.
So the double bond is, what it's saying is that the double bond is representing 2 bonds between a carbon and an oxygen, right?
Mm-hmm.
So you have to show them. ħajkollna bżonna f'waħda hawnhekk f'lef.
Okay.
Dal-każ fil-fatt ma kienx hemm bżonna daqshekk avvanzati. Okay? Peġġejtilkom xorta ħanibdew nirrepetuha iktar minn darba.
Okay, thank you.
Now, we now know that ħatara f'lef ta' naslu għalli. Priority huma 1, 2, 3, 4. Now, is the hydrogen at the back? It's at the front. Therefore, we can't just say 1, 2, 3 are clockwise, okay? And therefore, they're done. You have to go and say, the structure is going to be. And I know some of you will not agree with me, but 3, 2, and once we rotate it to put the hydrogen at the back, the oxygen will be at the front. Now, to do these, build the structure, okay? You don't need a lot of blocks. You just need 4. You've already assigned the priority groups and have, for example, the white dots or white color being 1, 2 being blue, 3 gray, 4 green. First, establish what you're given. And once you establish what you're given, then you can actually build it properly and rotate it so that the lowest priority group is at the back. Do build them, including in your exams. Even if your exam is gonna be here, I will tell the faculty you are allowed to get building blocks or plasticine and toothpicks to build them. Okay? And there will be no borrowing. So if you got them, you got them. If you didn't, you didn't. So this is going to be counterclockwise. And since it's going to the left, it would be S. So all I want to do for now is whether they are S or R. Now,
Okay, so the H, you ignore it.
You put it at the back, then you ignore it. Once you put it at the back, then you're going to look at the highest 3 priorities.
Okay, thank you.
Okay?
Sir.
Yes?
Ġifiri, meta il-bond tkun bħal tal-OH, toħodha li dejjem edha fuq wara.
Meta
jkun il-linijek, dik tfisser edha fuq wara.
Dik dejjem hekk tfisser.
Alright. U l-oħra triangle edha fuq quddiem.
Fuq quddiem hija triangle. U fuq wara hija l-hedge. Fuq
quddiem imma tiġi fuq l-istess plane mal-carbons?
Le. Il-carbons are on the page.
It's coming out of the paper, tipota.
It's coming out of the paper quddiem.
Alright. Okay.
Okay.
Thank you.
Welcome. Now,
sir.
So let's look at B. Now, B is a bit easier because B, okay, the hydrogen is already at the back. So the priority groups are going to be 1 for the chlorine, 4 for the hydrogen. But now we have a bit of a problem because 2 carbons and what's adjacent to them are all carbons. So we have to draw this out. Okay, so we have the chloro, hydrogen, carbon, 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 carbon. And this is where pentametoms will become important. Now this carbon has
sir, all I'm seeing is B right now.
I know.
Right, okay.
I know what you're seeing, don't worry. Okay, so I open that up, okay? Now, in the benzene ring, each carbon has a double bond. to another carbon. So pretty much each carbon would have a phantom carbon attached to it. So let me show you the original structure. Okay, you have a benzene ring. So if I want to remove the double bonds, I would add a phantom carbon for each different bond. Okay, so I would have up to 6 phantom carbons. I avoided drawing the last one on purpose. I avoided drawing the last carbon on purpose. I don't need it here. So when we're comparing the carbon, the first 2 carbons are the same. Then we go to adjacent carbons. And those are the same, and same. So then we would go on 1 carbon more. But the left, you've got carbons. On the right, they are all hydrogens. So the priority will be 1, 2, 3, 4. With this in mind, with that in mind, we can simply say that this is 2 and 3. 1 to 3, this will be clockwise. Therefore, it will be R. Okay? Clockwise. Yes?
Fuq il-pin ġejt. Għawek. Meta wasaltaw il-pink l-istess? U batċet ta' xtara?
U bat ħanaraw xem pala third carbon, right? So, give me a second. Sorry. Madam. Let's try. Now I try to draw them all green. Then you go and see what's attached to them. And to the right, only hydrogens. To the left, you have some carbons. Because there are only hydrogens to the right, then the carbons will win.
Okay, thank you.
Okay? That's anti-clockwise, by the way. Okay? That's anti-clockwise.
So it would be S.
No, R. I made a mistake. I wrote it correctly.
But
Tibtuni
the
fid-dubju.
4 was anti-clockwise and S.
One second. Għax tikerfixt. Skużawni. Għandkom raġun. Yes. Yes, it is okay. Yes. That is rotating anti-clockwise. Good, you're right. Yes. Now, same here in C would be something similar, but before we do C, Let's actually do H, because H is actually quite important. Okay? Compounds like H are actually quite important. Why? H, I can immediately quickly assign the groups as 1, 2, 3, 4. I have a CH3, so I know that any other carbon will have a highest priority. So I have a CH3 here, okay? So I know that any other carbon will have a higher priority. Now, this means it's clockwise, therefore it's R. So this carbon here, it's R. The other carbon, okay, you have to start all over again. And you've got something similar. It's symmetrical, so it's 1, hydrogen will be 4. There are no hydrogens over there. There's a bromine on the left, okay? So this would be priority group 2 and priority group 3. Now, for this one, you would need to put the bromine at the back. And you'll end up having something like this.
Sir, bromine jew hydrogen tpoġġi fuq wara?
Sorry, hydrogen at the back. And bromine would be at the front. So you'll end up having something like this, where you have 1, 2, 3, and this is anti-clockwise. So it will be S. Something else you might want to do, okay? Something else you might want to do is, instead of trying to put everything at the back and the hydrogen at the back, forget the hydrogen. Assign the priorities nonetheless. So hydrogen would be at the back. So you need to assign to 1, 2, 3. So this would be 1, 2, 3. Assign that now that is clockwise. Therefore, R. But hydrogen was not at the back. Therefore, change in stereoisomer. Therefore, yes. And the answer would be yes. Mela, what did I do here? Instead of saying, listen, let's complicate life by shifting the molecule, I kept in mind that hydrogen was not at the back. Now, because you have 2 carbons on the same plane, what that means is that when you change from an atom being in front to the back, we are literally going to change from R to S. Okay? When you rotate, you are changing from R to S. So if the priority group is on the front, it will be S. If it's on the back, it will look like an R. On paper, not in reality, because if you're playing with the structure, it should remain the same. So instead of drawing the structure the other way around, you can work with what's given. Note that you have the wrong orientation of the molecule, and whatever answer you get, change. Okay? And whatever answer you get, change.
Could you repeat
This
this?
is all, yes?
Sorry. Could you
Repeat, please.
Repeat the point.
Repeat.
Can you please repeat this point?
Okay, yes. So, what I'm saying is, whenever, and you can write it down if you want, whenever the 3D structure does not show the lowest priority at the back, find the RS notation. Okay? And then change whatever answer you get, because that would represent the fact that the hydrogen was not at the back. Okay? So if you get an R and the hydrogen is at the front, if it were at the back, it would be the S. Now,
And you know that it's not at the back because there's the bromine showing that it's at the back.
yes.
Okay.
Now, again, for me,
Sir.
so 1 second. For me, to get these right, build the structures. Okay? Do yourself a favor and build the structures. There will be a tutorial on these. And in the tutorial, I will actually be here with the structures. So as I told you for tutorials, I will want you to be here. Okay? Maybe you can't fit all of you, though today you are 41, so if most of you came, you would fit.
Did you check if perhaps the ICT auditorium is free at this time?
I've had no reply, even last week. So last week I went to check for different rooms. I think they are trying to put us and leave us here in science. Not necessarily in chemistry, but in science.
Chemistry is in the ICT auditorium, the analytical.
Listen, I'll check again. Because I have some lectures in Gateway this year because of COVID. So I'll check again. For me, the auditorium would be better, even to write, because I can record it using the apparatus, the lecture capture they have there, which would be a lot easier even for me. But we'll see. So G, okay, at the back you have the hydrogen. Yes?
Ġviri R u S jiddeskrivu jekk hux anti-clockwise u clockwise.
Yes. And then in the last lecture, okay, so next week we'll do the tutorial. And in the last lecture, we'll do the full naming. Okay?
Ġviri il-dan ħajaffet one naming.
Yes. I mean, for example, this G is 1, 2, 3, 4, 5, 6. It's hexane 3,4-diol, right? But now we have to see if it's RR, RS, SR, or SS. Those things without I didn't do the naming today because last week there were quite a few students who asked for the sheet for naming, for the worksheet, and I sent it, but I have not sent them the answers yet. So I'm giving you a week chance to actually do the answers, and then we can actually look at having a look at how to name these. Yes?
Ġifieri dik li konna nagħmlu qabel tiġi RS 2,3 bromo, le, 2,3 bromo hexane.
So that would be RS 2,3 dibromo.
Dibromo, right, stick.
Okay, but yes, but that's something for another time.
Ma ġifieri fl-aħħar hekk qed nibnu biex nagħmlu biex qed nibnu biex fl-aħħar nkunu nistgħu nagħmlu hekk.
Okay? Skużani qatali.
Ok, zej. Ġifiri, fl-axħar qed nibnu biex nkunu nistgħu ninnejmjawhom propja bla S notation speċi.
Iktar milli to name them, the main concern would be to draw them
Okay.
from the name. So remember, normally, it's not about naming something. There are programs for that. It's about drawing them properly. To design.
So if they give us the name, we can draw them.
Exactly.
Okay, all right. Makes sense. Thank you.
Now, G. Again, priority groups is 1, 2, 3, 4, 2, and 3. Whenever you have a carbon with those substituents, that would normally be the lowest priority group. Okay? So I did them wrong here because I'm an idiot. Okay? So this is clockwise or anti-clockwise?
Anti-clockwise.
Therefore,
it's us.
The other one, we're gonna do the same thing. One, two, three. It's
R.
It's still anti-clockwise, eh?
Yes.
So it's S. And normally, whenever they are on the same carbon with the same wedge, they would be the same. So this carbon bond, they are adjacent to each other. This would be, in fact, a mesoform. Okay? That is perfectly symmetrical. The two oxygens are opposite each other.
Sir,
Yes?
so if the worksheet you gave us, if we named it without the R and S, as in we do them again?
Of course, no. For the worksheet I've given you, I do not expect the R or the S. You don't know them.
Okay.
I told you to name them as if you were naming them for A-level.
Okay, thank you.
That's what you wanted to practice on. Because for all intents and purposes, this is what we're doing now. Okay? Now, I'll send you the remaining questions to try and draw them, okay? To try and do them, so that we can close the lecture here today. I will also upload, I will try actually to upload a video with me doing these with the shapes. So first, I'll discuss the priority groups, then I do the 3D structure, and then I can do it on the 3D structure itself. Okay? Because that is better. If I can't do the video, because it might be too difficult with the camera and holding it in my hand, then what I will do, I will take videos of the structure, photos of the structures, and post photos on a whiteboard, and then explain them there. Okay? So, with respect to the lecture for today, I will leave the floor for any questions, or if you have any questions, please ask, okay? Other than that, I'm gonna stop the recording because I will not be doing any extra material.